Welcome to a short demonstration of the Hedvig vSphere web client plugin. Hedvig is a modern, software-defined storage solution that's ideal for VMware deployments at scale. If you're looking to drive storage automation, especially in a multi-site and even hybrid cloud VM deployment, Hedvig is a great solution to simplify storage provisioning and management. The Hedvig vSphere web client plugin brings Hedvig functionality directly into the VMware interface. To start our demo, let's log into Hedvig's storage cluster. For this environment, we have 3 server nodes. We also have 2 Hedvig storage proxies shown here. In our virtual disk management screen, we see that there are already 3 NFS virtual disks configured. In just a moment, through the vSphere web client plugin, we'll see these disks from within VMware. Here in the vSphere web client, we see our Hedvig icon showing that the plugin is installed and ready to go. If we click on the icon, we see our management screen, and the first task to perform is to link our storage cluster to VMware. We do this by entering the name and login details for one of the server nodes in our storage cluster. What we see immediately is that the 3 previously provisioned virtual disks are now shown within the plugin interface. We also see our 2 storage proxy controller VMs. Now from here, let's provision a new virtual disk as a data store. We simply click Add Hedvig Data Store, and we're presented with a screen where we can give the virtual disk a name and input a size. We'll go with 500 gigabytes. You have a list of options to choose from, enabling you to custom fit the virtual disk to your workload. This includes deduplication, if we want to perform data reduction on this particular data store. It also includes replication policy, which lets us choose where we want replicas to be stored and how many copies. This can be to other racks in the data center or to other data centers entirely, including public cloud providers if we want to set up a hybrid storage cluster. Other options are compression, client-side caching to flash media, and the choice of whether to store data to hard drive or only to flash media. Hit Next. And for this example, we will choose a single ESX host onto which we'll provision the data store. We also input a data store name. Next, we choose the storage proxy controller VM through which we'll export and make available this particular NFS disk. Here we see a summary of the virtual disk, the data store, and the export, and we can hit Finish to complete the task. And we see our data store has been added successfully. We now see it in our list of virtual disks, and from here we can click and see the details. Let's jump back to the Hedvig UI and refresh. Here we see the disk we provisioned from VMware. Click to see again the details, the same information reflected in the vSphere web client. If we click through to our ESX host, we now see the Hedvig virtual disk under our list of data stores. Now let's go back to the Hedvig plugin. We'll provision another virtual disk, but this time let's look at how we assign a data store to a VMware DRS cluster. VMware's Distributed Resource Scheduler is used to load balance virtual machines across a cluster of ESX hosts. This time when provisioning, we select DRS cluster, and from here we can choose one of the clusters under management, and again we input a name. There are 6 hosts in this particular DRS cluster, so this time we can choose by host which storage proxy we want to use for our NFS export. We're going to use just the Wood CVM1 proxy, but you have the flexibility to choose individual proxies for each ESX host. In either case, this makes the data store available to each host, so no matter where the VMs are started, they'll have access to the underlying Hedvig virtual disk. To see that this operation was successful, let's go to each of the hosts in the DRS cluster and look at the available data stores. On each, we see that the same Wood Demo Disk 2 has been made available. A VM configured to use this data store can now migrate to any of these hosts. For this part of their demo, let's look at snapshots and clones. We've configured virtual machines to use our Hedvig data stores. Let's pick our AAA demo VM. We see that it's configured to use our Hedvig virtual disk. We may want to capture point-in-time snapshots or clone VMs so that we can quickly spin up additional resources. Hedvig makes this easy to do using our back-end storage snaps and clones via the plugin. In the menu, you'll see a list of Hedvig actions. This includes the option to take a Hedvig snapshot, to perform a linked clone, and to manage Hedvig snapshots. For the demo, let's do a linked clone. In our dialog box, we give it a name, and from here, once we hit OK, a snapshot is taken, so all writes are quiesced, and then that point-in-time snapshot is used for our new cloned VM. This is being performed using Hedvig's space-efficient VM-level snaps and clones, so it happens very quickly. We get a new VM without the overhead of copying all the files and data, which can be both time-consuming and takes lots of space. If we look at the details, we see the clone is using the same Wood Demo Disk 2 data store. Just to show this is a real, live, functioning VM, let's go ahead and power it on. We'll launch the console, and we see our Linux OS booting. This is just one of the ways Hedvig makes it easier to deal with storage for a virtual server environment. It gives you the flexibility to quickly provision storage with just a few clicks. It gives you options that help you drive better efficiency, and not just for the storage itself, but for your day-to-day operations as well. Thank you for watching. For more information, visit our website at hedviginc.com.